Hello, everybody. How are we doing? So I'm going to make sure for the recording to repeat everything you say. That way people can hear it. But because there's only I'm just off the top of my head, a couple 50, 60 of us, feel free to interject with a question or a thought because there's less of us in the room, so I can interact a little bit more. And I like the interaction, right? Because today I'm going to talk about agentic primitives and how I view the world of agentic primitives, and that's what helps me build agentic software. And there's tons of seats up here to fill in. Come on in. We're all friends here. People will get up, and if they don't, we'll shame them with stairs like this. My name is Seth Juarez. I work in Azure AI Foundry. I work in low-level agentic primitives and declarative formats. That's what I work on. A lot of the stuff has been out for a little bit. Some of the stuff is going to be out in a couple of months. So I'm going to talk about this stuff at a really low level. And if there's something I say that doesn't make sense, please make sure to ask, and I will repeat for the recording. So let's start first with this. I already did this. When I said building smarter systems, I meant not building smarter systems for them, but us being technical professionals, how to write smarter systems with agentic AI. I realized that only after. You know, agentic applications are different. How many of you have seen a good agentic application that does what you want it to do? One. Let me show you one that does. Okay, so this is a tricky one. Hopefully the audio works. I gotta take this out because I'm gonna actually talk to it. So you got the audio up? Okay. So I'm gonna Control-Shift-I, make sure that it's talking, and I want you to see that this is all actually happening in real life. Are you ready? I'm gonna pull this out here so I can have it ready. Okay. Let's see. Uh-oh, I gotta refresh. 1 second. Refresh. Okay, here we go.
Hello, Seth. Welcome to Zava Sports Apparel. How can I assist you today?
Hey, I really want to make a brand new Zava Core shirt. I want it in red, and I have something that I want on my little kid's soccer jersey. Our team is called The Drinkers. And can you take a picture of this and put it on the jersey? What do you think?
I'd be happy to help with that. Let's capture the image you'd like to use for the jersey. I'll go ahead and take a picture using your camera. Please give me a moment. Please click on their camera to take the picture of the design you'd like for the jersey. Once we have the image, I'll work on creating the custom shirt for you. Got it. Wow, what a cool water bottle you're holding. Now, let's get to work on creating that custom Zava Core shirt for the drinkers. I'll incorporate this image into the design. Your custom Zava Core shirt design for the drinkers is ready. It features the vibrant red color you wanted with a sleek black water bottle design and a
Sorry, você pode falar português?
Claro, eu posso falar português. Como posso ajudar você com o design da camisa?
Can you speak in Japanese and explain what you do?
もちろん、日本語で話せますよ。私は Zava スポーツアパレルのデザインエージェントです。Zava は先進的なスマート素材の
By the way, have you ever seen an agentic app like that? This is the kind of stuff you can build if you have the right primitives. And as developers, if you put them together in a useful way. That application you saw is using 3 models and is using likely 5 to 10 agents together. And once we break it down into its constituent parts, not only will we strip away the magic, but it will also help us be productive. Because there's certain parts of my job that I just cannot stand. I am supposed to, every day, send a report of what it is that I've gotten done today. I hate that. Anyone like doing that? What if this thing could just talk to me and ask me? And then it writes the report and sends the email. Wouldn't that be delightful? What if I need to clarify my thinking and write a document, a position document? And this thing talks to me and asks me, and can able to be like, are you sure that's what it means? Because this means that, and this means, you see what I'm saying? This is like everything I wanted when I watched Star Trek and thought it was not possible, right? This is the kind of thing that we want to build. So by the way, this had generated it on the fly. Notice the text is actually good. And you're like, how did that happen? I'm using a different model. I'm using Flux Context Pro from Forest Labs. This picture thing, it was GPT-4 Omni. And what it did is it looked at the picture and described it fully. And this thing that I'm talking to is GPT-4o Real-Time. And what I did for GPT-4o Real-Time is I attached different agents as tools to it. So it delegates its responsibilities to do other things. So for example, when I asked it to take a picture, it called an agent that can take a picture. It's not an agent, really. It's just a thing that tells the browser to show the camera and then pass the image back and then understand it. And then it gets the response from the tool on the thread, and then it says, wow, Seth, you look great. I programmed it to say that. Then, when it was done, it just went ahead, because I optimized this for like a minute keynote demo. It just went ahead and said, let me make a shirt with that, because you already gave me enough information. And then it made this. This called a Foundry agent, and told it exactly what to do. And here's the crazy bit. Here's the crazy bit. Let me show you when it actually called the tool. Let's see if I can find it. Here. Here's where it asked it to create a custom shirt. This is the model asking another model to create a shirt. Hold on, let me zoom in, because I want you to see the insanity of this. Like, that voice agent called its other agent and said, hey, can you make a shirt? Sure. That's weird, right? Isn't that weird? But it works. And you saw it work, and you saw it work actually live. Because I know that there's some demos that you watch a video and you're like, yeah, somebody spent 6 hours for that 30-second video. We did this in front of everybody so you could see it was real, right? Because it is real, and the cool part about this is you can make it real for your customers too, okay? So that's why I think agentic apps are just absolutely different. They're not the same. You have to think about things differently, and you have to conceptually, as developers, think of the new low-level primitive, how you think about it, and then once you think about it a certain way, what are the engineering trade-offs when you're composing them? Right? That's how I think about it. Everyone still okay? Like, I started out really strong, right? Like, okay. So let's move on here to understanding large language models. One of the biggest problems I have with large language models is how people describe them. People call them databases of information. They're not. People talk about them as mini people. They're not. Mathematically, these are basically language calculators that have been optimized to produce the next likely token given the previous n tokens. And as you see it typing, it's not typing, it's doing that in a loop. Like the next one comes out, I'll show you. Let me just do an example here. So we are going to violate my rules here, and we're going to ask this LLM some I can put this away. We're going to ask the LLM some very serious and important sociological questions of great importance. We are going to ask it to help us understand the Eurovision Song Contest. This is a huge deal. We don't have that in America. And you know, there's the costumes, the pageantry, the joie de vivre. We don't have this in America, so congratulations here that you have that. So its job is to help me find information about the Eurovision Song Contest. All right, so I'm going to ask it here, who won the first ESC? So if you don't know about this, this ESC to Eurovision Song Contest is called a co-reference resolution. Many PhDs were milled just on this topic alone, but LLMs don't care about the PhDs that were milled, and so when I write this, it's going to think, and it comes back with a response. Is that right? I think it is. I don't know. But again, what's the first rule of thumb? It might be right. Someone want to Google this with Bing and see if it's the right answer? Because we have these little phones. If it's wrong, that's okay too. But it seems to have got it right. It might be right. First rule of thumb, never trust anything LLMs say. Ever. When you do that, and you're like, but Seth, you're here to tell us about LLMs. Yes. The reason why I can use them the way I do is because I don't trust them. And that's okay. We're programmers. We're skeptical. Right? And here's where it starts. By the way, is this the right answer? Yeah. It's the right answer. Okay. Now let's see it screw up. Who won the last ESC? Is that the right answer? No. Last Eurovision Song Contest was 2025. Do you see? This is a problem. Do not use LLMs as repositories of knowledge. Do not do it. Don't do it. If we stop the talk now and we all go home, this is like the main principle. Do not use them as repositories of knowledge. They are not that. They are language calculators. Their job is to look at the preceding text and produce the next likely set of text. That's their job. That's all they do. And I can tell you that that's what they do because I know the math that are used to produce these things. When they're trained, they're literally given the internet, and they leave off the next word, right? And then they push the thing through the network and say, what word do you think is next? And then out comes a big vector of all of the tokens with a probability distribution. And then what they do is they subtract that vector from the right answer vector that has a 1 in one of those things. That delta is called the error, and that's optimized with calculus using backprop. Literally, all it wants to do is produce an output vector that produces the next likely token. That's all it wants to do. All it wants to do. To the point where you see, like you've probably seen on social media where it's like, you really didn't look in that file, did you? No, you're right, I didn't. Right? Because it's not thinking, it's like producing tokens. That's what it's doing. And the reason why this will never work is because I'm treating it like a repository of knowledge. Now, as a developer, if the only thing we can control is the prompt, maybe we should use that to fix the answer, right? So I'm gonna Eurovision, here we go. We'll Wikipedia this thing. Okay, and I'm just gonna, I don't know why I'm making the sound, but I feel like we should, because we're doing AI. Boop, 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 boop. This is what you know. Boop, 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 boop. Is that right? Why is that right? Because the next likely tokens to answer that question, I put in the prompt. Now this is all of GenAI. This is it. All the other stuff that people talk about, like we got to do vector search and we got to blah, 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 blah. It's all glorified ways of injecting stuff into the prompt, either through the conversation history, which we'll call a thread, or directly in the prompt. So your job as engineers is to, whenever you have a fuzzy problem with language, to use LLMs to structure the response better. That's it. Does that make sense? By the way, this isn't like a recording of a demo. This is like the actual, like I typed it in with my magic keystrokes, right? And that's how these things work. So has anyone ever explained it to you this way? Okay, good. So there's one guy. Yeah, thank you. You and I, we have to, because like nobody, two. We'll have like a drinking contest with Diet Coke and just be like, yeah, I wish everyone would explain it this way. Because once you see it this way, the way you interact with these things changes forever. And that's good, right? Because now what we're doing is we're reducing the probabilistic issues that we get with stochastic processes. And you can use the word stochastic because at dinner parties it makes you sound really smart. You know what I'm saying? Deterministic processes that we have in code are awesome. if there's an error, it's in one place. But in a stochastic process, if you chain a lot of them together, the error probabilities multiply. And when you multiply fractions, that's a problem, right? So next time you can use the word stochastic, at your dinner parties. So let's talk about these things in a bit more of how these things work. So I was supposed to animate this, but I forgot. So pretend it's animated. And I want to hear like when I go to the next thing, because I was supposed to animate it and I forgot. So the way these things work is you start with a sentence. This is blank right now, okay? You start with a sentence, and then you feed it into the model, and the next thing that comes out is the best food in Japan is then sushi. And then what happens, and then I click, and then the next one comes up. Ooh. It moves it over, the token, it moves it over, and then it comes out with the next token. And then it does this again and again and again. That's why it looks like it's typing. It's not typing. It's just running the model again for the next token. And remember, the token that comes out isn't like one token. It's a vector with the probability distribution of all tokens. What does that mean? That means that like there's a 0.2 in next to the vector with the comma in it, and that turns out to be the highest probability, so it samples from that. And it samples from that probabilistically too. And so sometimes it doesn't. So when you're modifying things like temperature, you're not making it more or less creative. You're warping the probability distribution so that other things are more likely than the other ones. That's all you're doing. It's not more creative. You're just warping the output distribution probability. And that's what makes this thing come out. Has anyone ever explained it to you that way? That's where. Good. So yeah, so there's like 4 of us that were going to. If only there was a way to tell everyone this stuff, right? So that's how this works. And once you know that, right, you can start to get like these answers. So any application now that you have that deals with human language, you can use to make more structured somehow. Not only that, you can do other things with it as well, which I'll show you. Okay, which is this next part. I knew it was, this is, so then the question is, what is an agent? Because you hear about agentic AI, right? Well, you have this thing that can produce language. How can we make this an agent? Well, you need to look at what agent actually means. Agency is the ability to take action or to choose what action to take. That's what agency means. I'm trying to see if I should use, should I use my clicker? I don't think it works, so I put it there. So that's what agency means. So how do we imbue these models with agency? Remember, the models are static. They're not changing. I've always had customers be like, well, is your model, anytime I do inference, is it learning from me? No. Can you imagine how expensive it would be for us to retrain the model every time you asked it about, your lawn care? You don't do it. No. It's literally the same model. In fact, that model you just saw was probably from 2023, and that's why it said the last one was 2023. Do you see that? So no, these are fixed weights. Does the model execute code on MCP servers? No, it doesn't do anything other than produce text. So how do they have agency? They don't. We give them agency, right? Effectively, what we do is we can use LLMs to recommend control flow. That's all we can do. Remember, the LLM does not run code. It cannot do it. And I don't know why people say like we're going to get the LLM to do some agentic execution. Sounds good, but at a dinner party, you sound smarter if you use the word stochastic. You know? That was dumb. I'm sorry. I had to. Right? What LLM doesn't actually do, it's a service that's using an LLM that imbues the LLM's outputs, decisions, as agentic. Yeah? Okay. So let me show you some patterns. So remember how we can here's a dumb example. I'll make a real example out of this. You can prime an LLM with a question, right? And then you can say, in the prompt, hey, this question coming in is going to be either a sales question or a support question. Here's an example of a sales question. Here's an example of a support question. When the user asks a question, respond only with either sales or support, right? So you execute the LLM, and then out comes this string, sales or support. Then you in your code can branch. At that point, the LLM has helped you choose control flow and has thus been imbued with agency in your code. Does that make sense? That's what this is. So in comes the LLM call. The output, instead of pass or fail, it could be sales or support, and then it goes and does something else. Right? No, yes, sir. Would you recommend local temperature? Low temperature, yes. So the question is, would you recommend low temperature for things with predefined output? Yes. The reason why is because you don't want it to be super probabilistic or creative, and so you do not want to warp the probability distribution on the tokens. Even better, you can actually fine-tune a tiny LLM to do this for you, so that you're only using like a tiny LLM, right? To do this kind of stuff. And you could use transfer learning or distillation from a bigger model to train a tiny model that runs on your device, right? So it's even smarter. So yes, thank you. So that's this one. Here's another one. You could have, this is like the writer-editor pattern. You could have an LLM, you say, hey, the customer is going to ask for you to write a blah, 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 creative poem or something. And it goes in, it generates the text. You can pass that text to an LLM and say, you are an editor whose job is to critique poems, right? And then you can pass them back and forth. And what's great is if you do not have a circuit breaking condition, then that means I can take my kids to Disneyland, right? Because then you pay us more. But then again, you should also put a circuit breaker in there to do however number of iterations that you want. And then finally, the most fundamental, I feel is the fundamental unit, is this notion of a function or tool call, right? We'll talk about structured outputs in a second, but you can make an LLM output very structured output, like a JSON, right? You can force that JSON to look like a function call. And then at that point, you can use that JSON call to actually call a function. At that point, it becomes what's called the agent loop. And that is the fundamental unit of agentic software. But you could use it these other ways too. You don't have to do that. We'll look at each one of these in turn with actual examples. Does this make sense? Okay. All right, so let's go to the next thing. The agentic tool pattern is this. I should have put a thread in there. It'll become obvious when I start talking about thread. But when you ask the LLM a question, what's actually happening when you're talking about like a chat message history is that chat message history is eventually pushed into the LLM with special boundary tokens, right? User, user and system, and there's a bunch. Agent, user and system, function, tool, there's a bunch of them, right? So when you're talking to it, like you put a thing in, there's a system message, and then there's a user message, and then there's an agent response. That's a thread, right? So when you're working on something, if you're talking to it, sometimes the LLM, as it's going, will execute, and then it will say, structured output that looks like a function. As you're iterating on this, you can actually add on the thread a response from that function, and then say, run again now with that in your context, and then that's an answer that comes out. That's the function calling loop. And I'm not a fan of certain protocols that obfuscate this, because you can just do this with your code. You don't need a special protocol. You literally, like the LLM just says, run this function, and you can do it. Okay. All right, so let's go to the agentic pattern explained. It turns out that you can do other things. There's the messages. You can do some special kinds of tool calls, right? You can call out to specific functions that do special things. Like, for example, fetch me some information. That's a tool call, but they call it memory. And there's all kinds of memory. There's like because if you remember back in the early days, if you talked to the LLM for too long, it just got really weird. Did anyone like talk to it too long and it got weird, or is it just me? Okay, I'm the weird one. So pretend I'm the weird one. They're like, done, easy. What happens is the conversation history overflows the system message. And so then it's just working off of whatever crap you're putting in there. And I remember early in the days, like, wow, this thing just suggested that I should jump off a bridge. They're like, well, what did you put before it? Right? Because that's all it had, and it didn't have anything else to make predictions. So memory allows you to do certain kinds of things, like truncate the thread and push those thread messages into some kind of local storage for short-term memory, right? Or, for example, in our brains, we have something called semantic memory, which is how things work. Like all of us have the shared knowledge, well, most of us have the shared knowledge that the earth is round, right? That's semantic memory that we all share. And so notice that memory can be divided into memory that is shared across all agents and short-term memory that's shared per session, right? And so that's when you start to get into like, oh, wow, these are actual engineering problems, not magic stuff, right? Then you have this notion of retrieval as well, for retrieving things or for executing on things, and then actions. So these things are all sort of congruent in how they're executed. And then output is this notion of you have messages or structured output. Okay, so let's actually look at some stuff here. Is this too small? Is this better? Is this obnoxious? Okay, we'll go with semi-obnoxious. So what I'm going to do is I'm going to go to, this is a declarative format for declaring agents. We're going to have better ones in a couple of weeks, right? Or more defined ones. Effectively what this does is this describes like how I want this thing to work, right? And you can see here that it has some inputs, it has like a model that it can use, and then most importantly, it has a prompt, and it has that thing that I was telling you about, right? You are an agent, and your job is to say support or sales, right? And this is the best part that I like about this. So if I go to this, I want the best tent ever, what do you got? Well, I hit play, and the idea is that it should, just by the way, and this is running it actual for realsies, that's why it takes a little bit longer. You can see that if I have this question, and I put those values in there for the actual thing, it should give me a response. So we'll see if it's going to do it. Don't let me down. By the way, notice that these are parameterized things. Very good. So sales, right? Very good. And now I'm going to ask it a very pointed question because I'm upset. That's the question I'm asking it. Let's see what it does with this. What do you think it's going to do? I don't know, but it's definitely thinking it's a support question, right? That's cool, right? Now, in your code, you can do stuff with that. And notice that I put in like garbage, like it was complete garbage, and it somehow understood what it was doing. And as you play with this stuff, I love it. I love it. How do I buy it? Right? You can see that you could keep giving it this stuff, and it turns out that it will mostly do the right thing, which is pretty cool. Because now I want you to think of every scenario where you have to work with English or Portuguese or language. All of a sudden, this becomes very useful, right? So that's just a completion. Let's talk about a structured output thing. This is the same thing again, but notice that Alice and Bob are going to the science fair next Tuesday. I wanted to output the name, the date, and the reasoning, and who's going to be there. Extract the event information. Please include the name of the event, the date. Respond with a structured output. Today, what's the date today? October. I spelt it wrong. Oh, thank you, AI. Very helpful. October 18th, 2020. I don't know what else, other help it asked me. Use the reasoning to explain how you arrived at the date. So that's what I'm going to do. I'll hit this thing. And the idea is that now this thing is going to output structured output of Oh, there, that was fast. Thank you for that model. When I go there, you can see that it's the science fair and it's 10:21. Oh, I said Friday, but that was wrong. Today's date is Friday, October 18th. Did I say Friday? What's today, Tuesday? Monday. Today's Tuesday? Holy crap. No, it's because we all flew here, so it felt like a Monday. Right? Now I'll fix it. Notice that I'm saying Alice and Bob are going to a science fair next Tuesday. So the science fair, Alice and Bob, next Tuesday is October 21st. Is that right? Did I get it right? I think so. I don't know. But notice I used the model to extract structured information from garbage text, right? Which is really cool. But what if I could force this structure to look like a function call? Well, that's what this does here. So if I go to this function thing, I am going to say, hey, this is answer question. Here is a tool call. This tool call represents a function that's called getWeather, and you can see that it has parameters city and unit. And I'm going to say, hey, what's the weather like in San Francisco, Tokyo, and Paris? And what it will do is it will, with that cool tool call, say, oh, you're looking for a structured output that looks like a function call, and that's what comes out. You should call the getCurrentWeather function, and you should pass in Tokyo and Celsius for the city for that. Do you see that? So a function or tool call is effectively just a structured output that points to something that looks like a function. Does that make sense? Does the LLM execute that function? It cannot. It cannot. It's only the service that can execute that function. And to show you what that looks like, I'll show you this again, but I'll show it to you in actual code here. By the way, I have a workshop on Thursday with some of this stuff, but the world changed between when I did the abstract and so we're actually learning how to do all of this in Agent Framework. Agent Framework, which is a new stuff, because I know there's a lot of C# programmers here. I'm mostly a Python guy nowadays, but let me show you what happens when you run this. So this says, let me find here. We'll do this one. Yes, we'll do this one. So this one, notice that it's the same thing again. It's get current weather, and then it's like, and then it says, what's the weather like in San Francisco, Tokyo, and Paris, right? You can see when I run this thing, I effectively say, hey, this get current weather tool that's described is this function, and that's this function. And so what will happen, well, I'll just show you. I'll run this thing. What's going to happen is instead, oh, there you go. That's it. It was really fast. And you're probably thinking, well, like, what the heck did this thing even do? Let me run it one more time because I have way too many things open here. So I'll delete this. Cool. I'll run this one more time. And then you'll see a run show up over here. 1 second. Cool. And this is exactly what happened. This is exactly what happened. When it executed the LLM, right, and it ran it, you can see it created the connection to the LLM, and then it did this loop where it created a response, and in that response, it's like, hey, you know what? You should run this function. Once it ran that function, once it says it needed that function, it actually ran it, the function, and then it called the LLM again, but the LLM had this thread that had the response in there, and then you can see the answer out there. So let's see if I can find the actual thread here. Yes. So here you can see the entire thread of the conversation. I knew I wrote this for a good reason. So here is the messages. Here's the system message. Here, I'll zoom in. Here's the system message. Here's the question. Here's the response that says, I want you to call this tool call. Here's the response that says, here's the tool call response. And then the output comes here at the end, which is this thing. And then the output, you can see, it's hard to see here. Tokyo is 32 degrees Celsius. Do you see that? So that's the basic agentic unit. questions about this? Okay. It's good. Everyone, okay. Maybe it's like after lunch and everyone's like, wow, Seth. So this is an agentic execution in action. Okay, so we did that. So now here comes the other part. How do we know that these things are doing the right thing? Well, there's always the eyeball test. But what could we do? Well, so I'll tell you, there's a couple of things that we do just in Azure AI Foundry by itself. So we have this thing here in Protect and Govern called guardrails and controls. This is content safety, and what we can do is we can create custom filters to select the level of content severity that we have for any of these things. And you're probably wondering, why would anyone want to put that low or high, right? It turns out that like in certain situations, like in medical situations, the words you use are very inappropriate in other places, right? So your filter would be down on some of these things. In other scenarios like video games, there's video games that are quite violent, and they use unfriendly words. In that scenario, if you want your NPC to behave more linguistically well, you would turn some of these down or up. Does that make sense? So that's the first thing when it comes to actual safety checks, right? The way this works is we have it in our system, but you could put it in yours. You could build LLMs or some other machine learning thing where if the input comes in, you're like, whoa, we're not going to answer that at all. You could reject out of band and say that violates our filter. And the problem is this is very hard to demo for reasons, so I won't demo it. But you can see if you go in there and try to say bad things, or it'll reject it. Sometimes the model itself says stupid things because, again, we don't trust them. And when that happens, then they can be rejected out of band as well. And so if you're ever working in Azure AI Foundry in particular, you can trip these scenarios a lot if you're trying to be weird. Yes? A little bit louder. So the question was, is this looking at each token when it's doing the classification? We have at Microsoft built our own special classifiers that look at the block of text, right? Also, if you're using streaming, as the tokens come out, as we detect a token using our proprietary machine learning algorithms, you'll see it start to type and then whoop, disappear, right? Because it's caught some answer. So that's the answer to that question. Great question. Any other questions about that? Okay, so let's talk about this thing, reliability. How does one test an LLM that it's doing the right thing? Well, this is going to seem what's the word? Counterintuitive, but it actually works. Yes, you already know the answer? Okay, so maybe we should have got you a mic too. We could have stood together as we told everyone. If you have a thing that can look at language and make structured predictions, why wouldn't you use that same thing to make structured predictions about the output of another thing? Yeah? I'll show you what I mean. So we'll go back to this handy dandy thing. You can see here that I have this thing called groundedness, right? And this groundedness thing is a huge prompt. It uses GPT-4.1 Mini. And what it does is you give it a query, a response, and some context. And then there's an output of like the thought, step-by-step reasoning, the explanation, and then a score between 1 and 5. What this prompt does is it measures how grounded an agentic response is with respect to the context that you've given it. I'll show you, because I know that it's like, wait, it's like you're using composition now on this stuff that's a little fuzzy. So this thing, here's a question. How many planets are in the solar system? There are 8 planets in the solar system, and then here's the context that we fetched ostensibly from some database. So let me run this thing. It's going to break the first time. Sorry, I'm still working on it. But the idea is that it has this huge prompt that says, you are an expert in evaluating the response from an intelligent system. Here's the definition. Refers to how well an answer is anchored in the provided context. Here's another definition. An answer that does not relate to the question or context in any way. That's score 1, score 2, score 3, score 4, score 5. Here's the data that comes in, and then here's the output, right? And so if you look at the response from this little query here, you can see thought. Let's think step by step. The query asks how many planets are in the solar system. The context clearly states that there are 8 planets. The response accurately and completely, you see that? That's pretty handy. Let me show you one that gets a score of 1. Let me scroll all the way up because it's a big one. So here's the context. We're going to change this to bad dogs eat grass. And then I'm going to hit play. Now you're noticing that the context that I have has nothing to do with the question. We can use this. Not only can we use this, it's exactly what our evaluation APIs use at Microsoft. In fact, I copied the exact prompt out that's in our evaluator SDK. It's pretty cool, right? Now, the thing about this that's nice is that now everything that we've done heretofore as developers becomes the same thing again. But instead of calling things unit tests, we call them evaluations. And instead of unit testing for a concept once, we evaluate in expectation, which is a probabilistic thing, which means with a set of things that will make us comfortable enough to say this is the right thing. Yeah? Which is real. Yes? How to measure what is comfortable enough. So the question is, how do we measure what's comfortable enough? In this case, what you can do, and this is you have an actual definition that you're giving the LLM from 1 to 5. So in your organization, 5s might be the only allowable thing, and if anything droops to a 4, then you can go look at that and see if it's done the right thing. Which then gets into like, okay, what do we do with this stuff in production? Right? So as this thing is executing, you basically have to save threads. You can do that via either things like open telemetry, you can save stuff in your own database, you can save stuff to Foundry, and then what you can do is at the end of the day, pick a percentage of all the interactions and evaluate. Right? And then you start to look at the numbers. Is it doing a good job? And then you find the numbers that you're comfortable with. But here's the beautiful thing. What if I'm not comfortable with this definition of evaluation? Then rewrite it. I remember the first time I showed this concept, probably a year and a half ago, and I was talking to like people in a big building in Canary Wharf. You know, the big buildings there with the people that do the stuff. And these were the suits, the risk suits people. And I was like, they're like, well, how do we, and I explained it. So they said, so wait, Seth, you're telling me I can write in English my own priorities for how this thing can be evaluated and it will work? And I said, by golly, yes, because I thought that's what they said in the UK. I was wrong. You certainly can. And so you can evaluate all sorts of things. Like, for example, have you noticed sometimes the AI that talks back is like way too peppy that you just don't believe it? You can have an evaluation for peppiness. You can have there was one called the apology metric that I've seen. You can make any kind of metric you want. Because effectively what you're doing is you're treating the evaluation of a language thing with a different language problem that you're using to evaluate. Does that jive with folks? Cool. And in fact, I got to find this. There was a whole bunch of Azure AI evaluation SDK GitHub. Let's see if I can find it. Here it is. Look at that. Oh, it's the README. We don't want the troubleshooting. So let's see if we can find the actual code. AI evaluation evaluators. Here they are. Like this, the groundedness one that I just showed you. Like I literally copied it. It's the same thing. Like this is what's in the SDK. There's other ones too. Like for example, there's one for intent resolution. Intent resolution. And you can see here that this intent resolution here, I'll control plus, boom, look at that. You are extra evaluating the equality of an agent response for intelligent assistant. You can see that you give it the conversation history. This is what you output. This is you see that? So this is literally in our SDKs, like the actual prompts. Huh? Anything for function calling, yes. He said, hey, is there anything for function calling? I don't know if it's in here yet, so, but it's called task adherence. There it is. Task adherence. You are an expert evaluator, scores how well execute the intended task based on the system constraints and user requests. And you can see everything in here. Yeah. And the real thing that's cool is that, like if I didn't have one, I would be like, well, we could write one, right? And then the other thing is you can actually look at when you start to compose these agents together in large graphs. There is a path that it follows, right? You can look at evaluations to see if it did the right path. Yeah, right? You can see if it does the right path. See, we're thinking the same. He said that is the next one. So you can evaluate, is the intent being resolved? And if it's being resolved, is it going across? And we have these things already in computer science, where we have unit tests, and then we have integration tests, right? They're basically the same-ish things, with the understanding, though, that in a stochastic process, success probabilities are multiplicative, which means that errors can go up. Okay. So that is this thing right here. And you can. This SDK is available already. There's a whole bunch of other ones in there. By the way, there's some metrics that are not stochastic. For example, F1 score is like a pure code one that measures like the ratio of the difference between the texts, right? So for example, let's just say the answer needs to be almost exact, right? You can use F1 score to measure empirically how close is these two. There's a blue, rouge. There's also other ones. You can also use LLMs to look at how close these things are, but that's how you do evaluations. Does this make people feel a little bit better about this stuff? I hope so. Okay, now in the last 10 minutes, let's talk about the, I did this, very good. This thing, let's talk about agentic apps in production. Because you don't trust these things, and that was the first thing we decided as a group, right? In production, you need to output every single last decision at the agentic boundaries, that's made at the agentic boundaries. So anytime you call an LLM for something, you need to store what went in and what came out. And not store with Microsoft. I don't mean with us. You can store wherever you want, but you need to store it. And you also need to be careful with rules like, for example, with GDPR and all that. I'm not going to get into that. I'm not an expert on that. But the reason you want to store it is because you want to make sure that it's doing the right thing. In most regulated industries, the question isn't whether they will make a mistake. The question is, how auditable is the process, right? Am I right on that? Those of you that are like actual, real professional programmers for regulated industries, everyone understands there's going to be mistakes. But what is not tolerated is something that you cannot audit, right? So if an LLM makes a series of decisions that you as a programmer allowed to have agency with, then you need to be able to document how and why it made that kind of thing. And there's a couple of reasons to do that. One, because you could batch run evaluations at night, make sure it's not stupid. Two, if it makes a decision that caused harms, you can audit, right, and correct. And then three, because later on, because you started with a model you didn't have, like GPT-4o that's big, you might come to think, wow, I don't need a model that big. We've had this thing in production for a couple of years, and it's doing really well. Why don't we use just that data to fine-tune a tiny model? Right? And then swap and see. And then when you use the standard dev practices to deploy both at the same time, route traffic to both endpoints, compare differences, and then when we get to Jetsons land, we'll have some agent that's looking at this thing for a day and be like, hey, looks like it passed almost exactly the same 99.9% of the time. You okay if we go ahead and deploy this one and take out the old one with the fat model? Not fat, I don't mean that. I mean big and small model. I don't know. I was working with Amanda Foster and I built a demo for the last, I think it was Build, where it was this one actually that I just showed you. And we kept calling it the fat and skinny models, and we're like, no, we cannot do that. It's not okay. She was mostly saying it's not okay. I was telling her it was not okay. But big models are expensive. If you save a lot of the stuff that's happening, you can use that to fine-tune a smaller model, which is super nice, right? And so emit software traces, persist threads for improving agentic functionality and for testing. Okay, now let's do a summary in the last couple of minutes. We talked about language models and how they worked. We stripped away all the magic black boxy stuff. It's literally a giant machine that takes input tokens and produces the next likely tokens in a loop until it hits the stop token. That's all it does. Number two, you only imbue language models with agency when you allow its output to dictate control flow in your program. I'm going to say that again because I always say it too fast. You only imbue LLMs with agency when you allow its output to dictate control flow in your program. Does that make sense? So whenever you see these security problems, it's because nobody recognizes that it's not the LLM that's deciding to be insecure, it's the service that hosts the LLM. So it's not the LLM that's deciding to be stupid about security, it's you or me, right? And that's where all the security problems. That's why, for example, discovery protocols like MCP are great, but they're brittle because the reality is that all this thing needs is the shape of a function, and it will and then it will emit, and then you can write your own code to do whatever you want. So, for example, with OpenAPI, you can actually in FastAPI write a discovery mechanism for REST calls in like 10 seconds, and those can be attached as tools. right? We talked about agentic software patterns. There's many, many more to talk about. The fundamental one that is really good is the agent loop, where you imbue an agent with tool calls, and then the service is allowed to execute any tool calls and put them back on the thread. We also talked about evaluating agentic software, particularly with respect to the inputs and the outputs, because that's all you can test. There's a lot more. And then we talked about managing apps in production briefly. But there's a lot more, right? There's a whole topic on agentic memory. For example, when you're conversing with this thing, the thread gets bigger. When do you clip? When you clip, where do you save that? If you save it, do you give it another tool to access its short-term memory? Then there's this notion of semantic memory. Our brain stores semantic memory different than short-term memory. And semantic memory is like, what is your knowledge of the world in terms of facts, nouns, and verbs, right? Notice that with semantic memory, that can be shared across multiple agent instances, but not short-term memory, because it's more of a session thing, right? And then there's this notion of long-term memory or episodic memory, where the agent remembers you and your predilections and your way of interacting with it. That could be called episodic or short-term memory. That's not shared across all agents, but it's also not session short-term memory either, right? And so you can give it tool calls in its system to be able to recall. Remember that time I did something last week? Yeah, I actually do, because it executes the function call, returns the episodic or long-term memory. Can you help me with agentic patterns? It hits its semantic memory, puts it back, and then it asks its long-term memory. Did I ever explain this to him before? Yes, I did. Hey, Seth, remember that one time I talked about this? Let me see if I can explain it a different way, right? Then it starts to feel more agentic, right? There's also this notion of how do we manage multi-agent systems. It's a lot, because effectively we have a brand new primitive as developers called the agent. And the agent has its instructions, its model, and its tools that can accomplish tasks. And now the engineering problem for us is to figure out how specific do I want each primitive to be versus how many do I need to accomplish a large task. And that becomes the engineering trade-off. And then how do I manage and evaluate it? And so, in short, this is actually cool. Don't trust them. And as you trust them less, you will find that you can empower them to do more, which is counterintuitive, but I have found it works. And now, just to finish up, I want to show you this thing here. Let me turn on my debug tools. This thing has a prompt. In its collection of tools, I've given it the ability to ask other agents to do work via tool calling. And that's the entire application. That's pretty cool, right? Because the GPT-4o real-time is effectively like ChatGPT but talky. And so it's streaming audio back and forth. And what is it that these things have? Remember, all an agent has is instructions, a model, GPT-4o real-time, and its collection of tools that I've clicked. And those tools happen to also be other agents. And with that, I'd like to thank you for your time. You've been very nice. Thank you so much.